Hi, welcome to Introducing AI. My name is Martin Kerm. This is a series of 6 webinars we're going to run over the next 6 weeks. We're going to cover lots of topics around the world of AI from Microsoft's perspective. We're going to talk about things like machine learning, cognitive services, bots, conversations as a platform. There's a load of stuff. We're going to be joined by local experts from the UK covering each one of those topics in detail. To go alongside that series, we've got a series called Code Behind, where my colleague Martin Beebe is going to really dive into the technical aspects of that. So he's going to look at code samples, more orientated towards developers and technical people. Throughout this whole series, please join us on Twitter with #IntroducingAI. You can ask questions on there. We're going to try and answer those as we go along. This week, I'm joined by Rob Fraser. Hi, Rob. How are you doing?
Hi, Martin. I'm good, thank you. How are you?
I'm very well, thank you. I believe, Rob, you're going to take us through kind of a broad brush of AI, kind of a keynote for the whole series for us.
Absolutely. So it's fair to say, unless you've been hiding under a rock somewhere, you can't have missed the fact that artificial intelligence is now the big new tech meme, the big new tech trend. Yeah. So what we thought we'd do with this particular program is kind of 2 things. First off, in the first half, we'll talk a little bit about what is AI. And what do we really mean by the term? And then the second half, a little bit more around what are we doing at Microsoft around AI, okay. What can you do as a customer or a partner or an individual developer, and what are some of the implications? Because obviously there's a lot of talk in the press around the implications of what AI will be. So, and we'll put pointers through to the other content we're going to have during the series as we go through. So just to kick off, obviously you'd be kind of thinking at the moment this is kind of the new dawn. The sort of artificial intelligence has suddenly emerged and become this big new tech trend. It's fair to say that what we're really talking about is the new dawn of AI, right? Because AI is a research, it's a computer science research. It goes back really to almost the first days of computing, back to obviously the work of Alan Turing at Bletchley Park. So what we're really talking now is about a real resurgence around AI. Now, it's interesting that AI has got some popular perception. Most people have heard of it. And a lot of this has been set by kind of the legends of AI from fiction and from films. So, you know, whether it's the Terminator, whether it's things like HAL from the masterpiece 2001, this idea of intelligent machines and that most of the storylines around intelligent machines, artificial intelligence being somewhat dark and sort of dystopian. So, that's led to a lot of conversation around basically what's the future bring when we start having artificially intelligent machines, and is that going to be something which is extremely damaging and difficult? So there's an element to that. We'll cover that when we get towards the end of more of the end of this particular show. But there is this overarching kind of theme here around it's been humans versus the machines, and some of the big landmarks that you may be aware of around artificial intelligence, like beating people at game shows or playing better than chess or Go and so on. This has kind of set this narrative up around it's humans versus the machines. And that's led to one of the interesting sort of conversation points at the moment, which is about replacement, the fact that the humans have become better at tasks the machines have become better at tasks than the humans, and therefore we're going to see a lot of displacement of employment, and that's the second risk we'd like people to talk about. So again, we'll come back to that at the end. But really, the key thing to address first is what actually is AI. Sure. I think it's important to understand that the term AI is more of an umbrella term. Right? Sure, so it's a term which covers a whole range of different kinds of technologies and sort of mathematical research and even bits of philosophy. Right? So it's a broad term. It's not just one thing. There's a broad set of things within it. So
not a product as such, is it?
Exactly. So one of the things within that broad umbrella term for AI is this concept of general artificial intelligence. So a kind of AI which can solve problems and can sort of work through problems in the same way that maybe a human would. You know, could easily sort of act as a general purpose assistant, for example. Okay. So that's certainly one area of AI research which we're interested in. There's extensions of that which start talking about things like sentience, the idea of being aware of yourself, so machines becoming self-aware. Right. And obviously that's the stuff of nightmares and a lot of fiction in terms of Skynet and the Terminator becoming self-aware and so on. But this general idea of, can we get machines to be conscious, I think it's very interesting, and it's a very philosophical debate, but it's not something that we're necessarily concerned with here. Right. Despite 100 years or so of brain research, we still don't really have any idea where consciousness comes from, how it emerges out of this massive connected tissue in our brains. And so really it's not something which we'll be particularly concerned about in this particular series in terms of that kind of strong view of what is consciousness and self-awareness in machines and what's that going to look like.
So we've got no plans to take over machines just yet.
No, not just yet, not just yet. But what we will do, though, is we'll explore some practical tools. And I want to sort of start off this by asking you a very difficult question.
Okay. Right.
So what's the answer to this sum?
6 times 5,
yeah.
30.
Well done. Very good. You've been practicing.
I have been practicing, yeah.
Since the last time.
Yeah.
Very good. Yes, very simple. So as humans, we're very good at solving these kind of problems, right? 6, 5, 7, 6s, whatever. Obviously, as the numbers get slightly more complex, it's difficult. I mean, unless you know some shortcuts for mental maths, the best you can probably estimate, so it's about 100,000 or so.
Yeah.
And of course, when you move beyond that to large calculations, it's not something which is easy for individuals to do.
Sure.
And then you get things like generating these kind of complex computer graphics. So this is obviously a picture from Halo. This picture is generated, this image is generated anywhere between 30 and 60 times a second, and it requires hundreds of millions of different calculations to work out how each ray of light's falling on the different parts of the image and or different parts of the model, and how that then looks and how you create these images. And this is really computationally extremely tough, way beyond anything obviously that a whole plethora of humans could do. But in computer science, we generated kind of computer architectures, things like graphical processor units, GPUs, which are able to churn through these calculations, hundreds of millions of calculations every second, and give us these kind of capabilities. So computers have got very, very good at computing and solving maths problems and running algorithms and programs. However, if you show a computer this picture, the best it can probably do is to say, well, it's got some blue in it. But if you look at this, what do you see?
I can see an ocean and a horizon. Yeah, you can describe the image.
So to us, that actually means something, has a context. This particular picture here, what kind of emotion is this person showing?
Well, she looks a bit disgusted or fearful, maybe.
And again, it's not something which a computer could look at and understand the emotion or the intent behind it. And then you get something like this. So how would you describe this particular scene?
Well, it's 2 women chatting by the looks of it, laughing,
And obviously, you can tell by looking at their emotions and their eye contact, they're probably friends, and there's a certain level of kind of confidence in each other, they're sharing a joke. So there's a lot of information in terms of how we look at faces and understand the interaction between people, which informs what we see and what we understand with this picture. And then, of course, we take that to another level when we talk about the written word. So when we read books and we write books, we don't just read the letters on the page, we try and understand what the intent behind it is and the story is. And obviously kids at school learn to do comprehension, which is understanding how different concepts and different parts of the text relate to each other to give real meaning. And then, of course, we get things like this. So I'm assuming that you wouldn't be too worried if I sat you in a car in this particular position and said, drive down the road.
It depends what sort of car it was, of course.
Yeah, absolutely.
I could be capable of doing that.
So there's tasks like that which involve both understanding what's around you, where the road is, where the road isn't. Maybe there's hazards. It's a very complex thing which requires a lot of different senses and a lot of input. And then finally, of course, in terms of data, if you think about the way that we work, we're very actually good as humans at understanding data and drawing inference from it, but only at a certain scale. As soon as you get very, very large data sets, or very fast-moving data, we're trying to drink from the social media fire hose, for example, it becomes very, very difficult for us as humans to process the information, take insight from it. So these are kind of problems, really, which computers don't, to date, computers haven't really solved particularly well. So that's really what we're talking about with AI. Under this umbrella term, we're really talking about a whole bunch of different tools and techniques and processes which enable us to do some of these more human-like or some of these more sort of advanced things. So whether it's things like planning and scheduling systems, or understanding knowledge, or recognizing speech, or autonomous systems. That's another word for self-driving or self-piloting vehicles. And things like analyzing patterns, whether those patterns are particular pictures or images, or whether they're patterns in vast amounts of data or fast-moving data. These are the kind of techniques that we're looking at with artificial intelligence and obviously trying to apply. So I thought, just to give a little example of this, I thought, what better than to talk a little bit about dogs.
We all love dogs, don't we?
We all love dogs. And in fact, the handsome chap on the left there, Image A, is actually my dog, Buster. What breed is Buster?
I'd say he's a Labrador.
Yeah, they're good. And any ideas about breeds B and C?
B, some kind of spaniel.
Yeah.
C, I'm not so sure. No.
Well, we'll see.
Some kind of, don't know.
So let's look. So if we just switch over, there's a website here run by Microsoft Research called What Dog?
Okay, great.
And so what we can do is I can go in there and I can pick up a picture of Buster on the beach, and we can process that, and it'll come back saying Labrador Retriever. Well done. Right. So you're 1 for 1 on that. You get your maths right, and you've got your first dog. So next dog, let's look at this one. This one here is an English Springer Spaniel.
Okay, so I was right-ish.
Yeah, exactly. Yeah. That's not too bad. And the final one, just let's complete the quiz. If I get a little friend here, it's actually an Australian Shepherd.
Okay, right.
Well, there you go. And obviously, this is quite an interesting site because you can pick up other kinds of pictures as well. So if I get a picture of Buster with his Christmas ears, for example, on, in this case, things of Weinerarmer,
right.
mainly because the structure of his face more than anything else, kind of the whole body. But notice, hasn't said he's a deer or a reindeer because of this structure here. No, it recognises that really what you have here is a dog. And you can have all kinds of fun with this site if you wish to. So let's get another particularly classy breed. Let's take this particular breed here. Apparently you're a golden retriever. Really? There you go. Well, gets along with just about everyone, strong and active, gentle and eager to please.
Well, that sounds about right to me.
Right. So
I notice you're not uploading a picture of yourself, Rob.
No, I wouldn't do that one at all. There's not many bold dogs. But anyway, so that's interesting. So yeah, we've got basically an AI here, a machine learning solution, which enables us to identify dogs. Great.
Okay, great.
Yeah, that's fine. Let's look at a couple of other quick things. If you go to a site called Microsoft Cognitive Services, you'll find here there's a whole bunch of different interfaces, different sort of AI algorithms or APIs which you can access to do various different things. So let's just pick up one of them, for example. If we let's start with computer vision. Let's do that. So we've done dogs. That's great. If I go down here and just pick up that picture of the sea that we showed you earlier, just click on that. Hopefully
this is the same image we had earlier on.
Exactly.
Yeah. Okay.
This Vision API processes it. You see it's loading it there. And when it's finished loading it up, hopefully what we'll get back is a description. Here we go, a description of the scene. And this AI has come back saying a clear blue ocean water. And notice here it's saying things like, it's very confident that you can see sky, water, ocean, the colour blue, and so on. Right?
Okay.
So it's now interpreting this and tagging it, say, clear blue ocean water. Let's try something else. If I let's just pick up another image, for example, and I pick up that road, for example, that we showed earlier, and we place that in and load that up, it'll do some analysis on it. An empty highway, and it gives you various confidence here that it can see a road, it's outdoors, it can see grass and so on. So that's pretty good. And if you pick up another image just to show you how this works, if we go to this one here, for example, this won't mean much to anybody outside of the UK, but this is a speed limit sign in the UK. You see it says a sign by the side of the road. Sure. So great. So if you show if you have a camera in a car and showed it this image, it would know there's a road sign there and potentially could interpret what it was. But this is actually more powerful than just those individual things. If I pick up one of my little holiday snaps here, so this is my son Tom. Okay. Any idea what he's standing in front of?
I mean, it looks like some kind of fighter plane or jet plane or something.
Yeah, so that's an SR-71 Blackbird,
right? Which
is the US high altitude kind of spy plane. Now, interestingly, we look at that and think, well, you can't see a whole plane. No. It certainly doesn't look like an airliner. Or anything. All we can see is like this engine intake maybe and a few wheels. Yet over here, the AI says a boy standing in front of a plane. Wow. Okay. Now it's never seen this image before. Yeah. Ever. It's never seen probably never seen that particular exactly. It's never seen that particular angle even looking at that particular plane. Yet it's able to infer that there's a plane, there's a boy standing in front of it. Yeah. So it's an example of what some of these algorithms do, which is they can generalize. They can basically be shown lots of pictures, and out of those pictures of, say, planes or people, it can kind of start generalizing and working out what's the essence of being a plane. That you may have something that looks a bit like a wing, you may have something that looks a bit like an engine. So that's pretty impressive stuff. Let's move on. A couple of other quick things just to show you. If we go to emotion, for example, on these cognitive APIs on the site, just wait for that to pop up. Okay, so we can pick up the picture of our person here. Okay. And have a look, and you come back here saying, "Oh, you're right." So it's actually 73% odd disgust with a little bit of anger thrown
sadness
in.
As well
the idea. So now we've got an algorithm here, an AI, which can start interpreting faces and human emotion. And actually, we can even go on to do things like speech, for example. So if I switch to another one of our services, this being speech one, if I go down, let me select English GB so it understands my accent. And if I just click on this for a second. She sells seashells by the seashore. Red lorry, yellow lorry. As you see, the accuracy in terms of now sort of picking up the speech and then being able to understand what's in the speech is something which is really now very, very advanced. Now, the interesting thing about all this is that these kind of capabilities, these kind of sort of things you've seen there around looking at emotion and so on, this is an example of something which we refer to as cognitive computing. Yeah. So this is the idea of providing computer algorithms, computer code, which essentially does things a little bit like we do. So whether it's understanding speech and text, or inferring meaning from speech and text, or recognizing objects, or dogs, or faces, or interpreting different scenes. That's what we talk about when we talk a little bit about this idea of cognitive computing. And so what we have here is coming up on the 11th of April in one of the series here, Your Good Self, talking a little bit around cognitive services and these different APIs. And I thought what we'd just show quickly is a short video. So Uber, the taxi firm, they've been working with us to apply some of these cognitive services to their particular service offering, and there's a short video here now of how that's working.
Okay.
We come to work every day to pilot, test, and launch new technology solutions. Real-time ID check is the latest technology example where we at Uber are constantly developing and testing new solutions to predict, prevent, and reduce security risks in ways that weren't possible before. It's through this partnership with Microsoft that we've been able to develop this technology quickly and ensure that every rider and every driver has an excellent experience. Real-time ID check is a prompt that appears in the driver's app, asking them to take a self-photo. We can do a check in real time to make sure that that identity of the person who took the picture matches the account holder who's been approved to drive. Doing that serves a couple of purposes. Drivers know that their identities and their accounts are being protected, and riders know that the driver who they're with has been screened.
Jen?
Evan?
Yeah.
Real-time ID is a smart technology. What that means is it factors in and addresses the edge cases. The situation where the driver is wearing glasses or a hat and they weren't in the identification that we have on file. The beautiful thing is it can recognize these changes and ask the driver to remove their sunglasses or retake the photo. The partnership with Microsoft Cognitive Services allowed us to go from idea to execution to implementation across the country in a matter of months. Already, we've been able to make thousands of rides safer, and very soon we're going to be making millions of rides safer through this technology.
So that was just a little example of how we're taking some of these cognitive APIs and customers being to use them to enhance their own sort of products and services. Now, what's interesting is, how have we done this? The point, but Arthur C. Clarke once said that any sufficiently advanced technology is indistinguishable from magic. And interestingly, the kind of demos I just showed you there with recognizing dogs from different angles and speech recognition, emotion, and so on, if we'd done those even 4 years ago, maybe even 3 years ago, there would have been mouths falling open. It would have seemed like almost indistinguishable from magic. So what's been the big acceleration of AI, and why, after years and decades of AI research, have we suddenly seen this explosion and acceleration? Well, it's important to understand a little bit about where AI was before we get to the more modern era. So if you think about classical AI, this was a period of AI very much through from its founding in the 40s up to potentially the mid-90s. The way we approach these kind of problems is a little different. So on the picture here, you see on the top right, there's that road scene.
Yeah,
right?
Sure.
So in old AI, in classic AI, what we would have done was, and what we did was, we apply kind of filters to it to try and extract features from it, like edges, right? Yeah. So you see the image underneath it is the edges of the road being picked up. There's a little wavy line at the top which represents the horizon. There's a few blobs here or there which represent some things by the road. But basically, the process was extract features from the image, like lines and build a model of how those features are related, and then try and tie that to some physical entities. So in this case, you might say, well, look, if we see two parallel lines and they converge at the distance, then let's assume that's a road. Right. But of course, this had very strong limitations, because if there's a fuzzy edge to the road, say it's a dirt road somewhere, or the road bends, or you get different kind of junctions forming, it becomes far more complex to really understand, extract what is road, what is not road, and yet let alone deal with things like, there's an animal by the side of the road that may run out in front of you. How do you identify that particular threat? So classic AI only got us so far. So what's changed? What changed has been a shift. And this is, if there's nothing else in this whole series, it's this shift which is the most important thing to sort of try and understand, which is that we're moving from a world where throughout computer science and the history of computing, we've always had the humans writing the programs, the algorithms, that sequence of steps, step 1, step 2, step 3, repeat, which were the instructions to the computer to solve problems. So solving a maths problem, here's the particular set of steps you do to multiply numbers, etc. Sure. Doing the shading on that image from the video game from Halo. We know how to write algorithms. We know how to write programs to work out whether something is visible or not, depending on where the soldier is and where you're playing, or what the lighting is. So we know how to do those kind of things. But what we don't know how to do is how to write a robust kind of approach that way to identify a dog, or to recognize faces, or to recognize scenes. And it's been that problem. We haven't known how to write the algorithms, the programs to do that, which has led to the kind of the problems with AI to date. So what's changed though is now is that we're moving from a world where we program the machines to solve problems to where we program the machines to learn how to solve those problems.
Okay.
And in doing that, in having the machines learn how to solve a problem rather than us programming them explicitly, we're taking inspiration from us humans, in fact from biology. So inside my head, your head, there's roughly 85 billion little cells called neurons.
Right.
And these are very simple little things. So they basically have a whole load of fingers, if you like, connections coming in. Yeah. There's a little center bit in the middle, which depending on how many electrical signals it gets on its input kind of connections will determine whether it passes those signals on or not, and whether it fires. And if it does fire, it then passes an electrical signal out across a whole bunch of outgoing connections. Okay. And some of these neurons can be connected to other neurons up to 10,000 times. Wow. So what you essentially have in your brain is a vast mass of these cells with a huge number, trillions, almost 100 trillion different connections between those cells. And basically out of that massive connections, and into very, very simple processing units, we get our intelligence, we get consciousness, as we talked about earlier. So what we do is we take inspiration from this and the way that we learn in terms of applying it to these particular AI problems. So for example, if we see a dog, or a child sees a dog and you say that's a dog, at some point, usually when you sleep, some rewiring and some reinforcement occurs in your brain. So it'll end up being the way we form memories is that we associate a particular image of a dog. We just have a label which says dog, and within our brain, some of those connections get strengthened between cells, some get weakened. And by doing that strengthening and weakening, we kind of store that image of a dog and say it's a dog in our brains, and that's how memories are formed. So our entire learning inside our brain is driven by the strengthening and weakening of the connections between these cells, and sometimes making new connections. Okay. So what we do in computer science is we kind of mimic that process, and I'll walk you through it. So this is an area called artificial neural networks. So here's an example. Here's just a schematic, just a basic diagram, where the little round dots are meant to be the same as the center of the neurons, the things that decide if they fire or not. And the lines are then the connections between them. And this literally just exists in a computer program. So you imagine that each of those circles is a particular kind of variable in the program, and the connections are just code connections between them. So we recreate that physical network in the software. So one side of it, we then take Buster. We break Buster up into pixels, and a bit like the retina in the eye, basically those pixels feed into the first, what we call input layer of this network. And then on the other side, we say, well, this is a Labrador, right? So we highlight the Labrador. And what the learning does, it then works backwards and forwards and kind of adjusts the weighting, adjusts the strength of those connections between the cells, such that next time that exact picture of Buster appears, the Labrador light comes on. Great, so we've done that adjustment. We then take another picture of a dog and do the same process, whether it's a greyhound or a husky or a spaniel, and another, and another, and another. And so in the end, we may apply 1 million, 2 million, 5 million images of dogs, dogs from above, dogs from behind, from the side, different breeds of dogs, and each time adjust subtly those weightings so that every time we see that exact picture, we get the right output. But something interesting happens when we do this is that what happens at the end is this network starts to learn what the essence of dog is and what the difference between the breeds is, so that it can then be presented with a picture it's not seen before and still do a very good job at telling you what it is. So it's that learning process. Now, this is a very simple picture here. You've got 3 layers of these little neuron programs. It turns out that in reality, these networks can have 100 to 250 layers. And the algorithm which then sort of enables us to do that learning, this is the area which is you may have heard of called deep learning. And this has been the real innovation. It has only been the last 5 to 8 years where we've understood how to move beyond 1 and 2 layer basic neural networks that we've had for a while to these complex, deep networks, which enable us to do this fantastic kinds of interesting learning. So it's been that innovation the last 5 to 8 years around deep learning and these neural networks has really driven this resurgence around AI. And so when we look at this, it's important to understand how this works. So with these neural networks, essentially on either side of it, you have data input and you have tagged or answer data on the other side. And then in the middle, we do the learning part. And this is key, because what this really leads to is the fact that this whole area of AI, we really feed on data. Right? So data and learning are kind of the yin and the yang of artificial intelligence at the moment, and that data is one of the key elements to that. Without the data, you can't do the learning, and without that learning, you then can't then reapply it and examine new data or new images or new photos of people's faces. So focus on data. And if there's one thing you do as a customer or a developer looking at how do you apply AI, the first thing you think about is how to get your data somewhere where it can be accessed and processed at scale, and obviously that's the cloud. Right? So that's really the first part. But the good news is there's a lot of data out there. We have our own data that we capture for ourselves, whether it be selfies or Fitbits we wear. There's our exhaust on social media. There's something we talk a lot to businesses about, which is digitize your business, get your data in some usable form. And there's things like Internet of Things, of course, which is grabbing data out of the real world and getting it up to the cloud. So there's a lot of data out there, which is good. Now here's an interesting thing. Here's some data. Any idea what this particular data shows?
Well, it looks like, is it maybe stocks of a company that's suddenly doing very well all of a sudden?
The stock price. This is actually, it turns out, this is the stock price for NVIDIA, who make those GPU chips that are used for doing graphics processing. And as you see, in the last 12, 30 months or so, they've seen a significant, about 400% increase in the share value. All of that's been driven by the fact that this machine learning process, this ability to take data and do the learning with a network, requires an awful lot of compute. And it turns out that compute power can best be provided by these GPU chips. And so if you're training your own networks and doing that kind of deep learning kind of stuff, then you're generally doing it using these GPU chips. And that's really just a market data indicating how fast this particular market and thing is growing. So interestingly, as part of our series, one of our colleagues, Bianca, will be taking us through what deep learning is and how it applies very shortly. So, sorry, as part of the series. So within this, what's Microsoft doing? So we've been leaders in AI going back to the foundation days of building Microsoft Research. So Microsoft Research was founded over 30 years ago, and we've been world leaders in AI research ever since. There's elements of that which you may not even be aware of. So one of the very interesting stories here is to do with the Kinect, the sensor on the Xbox. That's a $99 piece of kit which enables you to track movements and even track the pulses of people in the room by looking at the infrared signature of the skin. The way that was created, though, was that we generated millions and millions of artificial sequences of people dancing around. So we generated the training data. Then that was applied to a neural network using deep learning to enable us then to move from moving hands and arms around to actually then having a program be able to tell you where the body is and where fingers are and so on. So that skeletal tracking was done using this neural network deep learning technique, and one of the first products in the market which took advantage of that. Other areas which we've excelled have been areas particularly around things like object recognition and speech. And in fact, last October we passed a bit of a milestone where some of our MSR Microsoft Research colleagues, they reached human parity in conversational speech recognition. So there's a standard test, which is called the Switchboard Speech Recognition Task. And we reached a word error rate of around 6.3%, which is at the same level as a skilled human operator. So that's been really really kind of interesting stuff. So at that point, let's just take a quick pause. So far we talked a little bit about what AI is and some of the tools and techniques that are in that umbrella term of artificial intelligence. And we've also talked a little bit about how deep learning and the ability to train one of these networks from data is at the core of this resurgence of AI. So what we'll do is take a quick pause. And what we'll do then when we come back is we'll talk a little bit about what we're actually doing at Microsoft with AI, what you can do as a customer or developer with AI, and some of the implications.
Okay, great. Thanks, Rob. So we're going to show a short video now. Whilst we're looking at that video, feel free to dive in with questions on Twitter on #IntroducingAI, and we'll see you in a few minutes.
So think about this. How often are you alive when the dawn of a new medium comes out? I knew that I had to be a part of VR because there are no rules for what VR should be. Starship Commander is a choose-your-own-adventure VR narrative that uses natural language processing, so you can actually have a real conversation with the characters.
I'm Sergeant Sarah Pearson. I've been assigned to your wing today.
When we started making Starship Commander, we had to figure out how do we get technology that can understand what a person's saying so that we can have these new narrative experiences? We're a science fiction game. We come up with new words. No off-the-shelf software could let us put in custom words.
Who are the Echnians?
In our story, the bad guys are called the Echnians. And every time we said Echnian, it would come up with really weird words that were similar to other things that you would say. And so it would get confused all the time. So we needed to make sure that we could supply our own script. We started using Microsoft Cognitive Services to power the back end of Starship Commander.
Looks cool.
Once we plugged custom speech service into Starship Commander, I had tears in my eyes when I was playing it because it's like, oh my God, this is it. This is the experience we want.
Open the hatch.
Voice print accepted. Welcome, Commander.
You can essentially put your script in there and it knows, oh, these are the ways that people are going to talk. And these are the phrases that they're going to say.
Cool. What's my mission?
Must be something pretty important.
And then the second thing, too, was the intent detection. With Lewis, you basically give it a couple statements. After you've given it a couple statements, you crunch it and you start typing in your own statements. And it's shockingly scary how good it picks up, even stuff that you didn't put in there.
Computer, use autopilot and let's be on our way.
Autopilot engaging.
I've never seen an opportunity like this, where there's a wide open playing field, no one's written the rules yet, there's going to be tons of amazing software out there, and I just can't wait to see what other people write.
Hi, welcome back. That was an interesting little video there about Starship Commander. There's a lot of speech in that video. We've had a question from Mike on Twitter, Rob. The question is, will speech be the only way we'll interact with computers in the future?
It'll be a key way. It won't be the only way. I mean, for certain tasks, you're going to need a desktop and a big screen, and you'll need a mouse and so that. But in terms of speech, the really interesting part of that discussion is the idea of what we call at Microsoft ambient intelligence, the idea of intelligence that kind of surrounds you and you can interact with seamlessly. So whether you're at home, whether you're in the car, whether you're on the working on your desktop, the ability to use speech is a way of augmenting the way in which you interact with computers. So think about it as a key channel, absolutely. But it won't be the exclusive way in which we interact with technology. But we'll come to some elements of that as we go through the discussion.
Okay, great.
Cool. So obviously, prior to the break, we had a quick chat about what AI was and some of the technologies involved. So switch gears a little bit now and think, actually, well, what are we doing and what can you do with AI and what are some of the implications? And for Microsoft, where we're thinking about this, and where Satya Nadella, our CEO, has talked a lot, is about the importance of making AI sort of broadly accessible. Right? Yeah. And so what I want to do is talk a little bit about the technology of that. What are we doing to democratize access to AI the same way we democratize access to PCs back in the day? And then talk a little bit more about what that really means in terms of some of the implications. Okay. So at Microsoft, we've basically got three kind of lenses on how we're bringing AI to market right now. Through our own applications that we sell, through building our intelligent cloud, and through things like intelligent agents and bots and this kind of voice interface. So let's just quickly skip through some of those. So Skype's a great example of this. Obviously, everybody's aware of Skype, and you can make video calls and voice calls. But we've had the ability for a while now to do language translation within Skype. Okay. And based on the research we've done, we've now got this ability to really think about bringing people together in terms of different languages and sort of all in sort of group conversations. And just to give a little example of that, we've got a very, very short video here just showing a little example of our translation services working. Okay.
This is a new multi-device translation feature on the Microsoft Translator application.
Si tratta di una nuova funzionalità di traduzione multi-device sull'applicazione Microsoft Translator.
Wir können eine echte Konversation halten über die Sprachbarriere hinweg.
Possiamo mantenere una vera conversazione attraverso la barriera linguistica.
Et il est possible de parler jusqu'à 10 langues différentes.
Ed è possibile parlare fino a 10 lingue diverse.
100 people can participate in the same conversation at the same time.
100 persone possono partecipare alla stessa conversazione allo stesso tempo.
So what you're seeing there is it's the ability to have a conversation in 10 different languages amongst almost 100 people and really break down some of those barriers around communication. Now, clearly, there's reasons to learn language still. You know, we're not saying that. But the ability to sort of enable that communication using the machine translation, speech recognition technology we have is obviously very, very important. Other areas, if you think about how we apply AI and insight from data into our things like Office 365 and our kind of commercial products. We have this concept around organization intelligence, which is how do you think about the data within your organization, the flows of information, who's saying what, the context around those communications, so you can get better insight into the network of people and data and documents and activities and collaborations within inside the company. So very much applying AI and machine learning techniques in those particular areas. So you know, whether it's on Skype, whether it's with some other applications, we're adding intelligence into our CRM products, for example. We're bringing AI to market through the products which customers can sort of consume from us. Okay. The second element then comes to one of our core objectives of Microsoft. So we have these 3 bold ambitions of Microsoft, which is to, you know, reinvent productivity and business process. It's to create more personal computing, and the core of it is this idea of building the intelligent cloud. Okay. And this is very important to us. So you've seen some elements of this already. So the cognitive services, those APIs which we showed earlier, they're available off our cloud platform, and you can just integrate with them with a few lines of code. Right? So that's that's already there. On top of that, we have a whole range of services built into our Azure platform, and heading of Cortana Intelligence Suite, which enables you to think about ingestion of data. So, you know, picking up data from the real world using Internet of Things or loading your own data, creating vast data lakes of unstructured data, which you can then process scalably, both in terms of its size and the volume of data coming in. And then use things like our Azure Machine Learning Service to then do, you know, accessible drag and drop style machine learning solutions over that data to gain insight. Right? So very much we've got a strong set of services then we're bringing to market through the Azure platform around how you can take and transform data into intelligent action. And that's something which one of our colleagues, Amy, will talk about again as part of this particular series. So that's really important. Another part of what we're doing with Azure and the intelligent cloud is this idea of hyperscale AI. So we talked a little bit about the importance of these GPU chips in terms of the ability to do deep learning, to train those kind of networks. So we're rolling out those across our global Azure data center estate. But in addition, something we've been doing for the last couple of years is every time we roll out new racks into our data centers, Azure data centers, they've included these FPGA chips. That stands for Field Programmable Gate Array. And these chips are kind of like programmable hardware. So once you have something trained, like one of these neural networks, you can run them extremely fast on this FPGA hardware. To the extent if you took all the FPGAs inside Azure at the moment and set them a significant task, like translating the entire volume of English Wikipedia into Russian, it would do it in literally about a tenth of a second. Really? Wow. Blink of an eye. So very much high scale, hyperscale AI in the cloud. So that's the second part of what we're doing. This idea we've got first party applications, so Skype and so on, and we're building up a whole range of services which customers and developers can consume, which start enabling them to build their own AI-based solutions. The third area comes back to our conversational subject here, the idea of conversation intelligence, and very much back to the question from Mike on Twitter earlier around speech. So speech is becoming a form, key form of interaction with technology and with computers. And what's interesting is, just think about the shift that's occurring here. So for the longest time at school, we've taught kids, and in the workplace we taught adults, how to interact with technology. So everyone had a keyboard, a mouse, a computer, maybe touch, but you've had to learn how to interact with the technology. The change that's occurring now is that the technology is kind of learning how to interact with us. And interact in a way that's natural, that's more personal to us, and it's more personal computing, and voice is clearly an important part of that. And there's two elements to really think about. First off is the kind of idea of the intelligent general agent. For us, that's Cortana. It's the ability to speak to Cortana, also you can use text, and have her understand what you're asking for intent and take actions for you. Okay? So that kind of idea of the virtual assistant. And that's really important to us, and we're pushing very hard, obviously, to get Cortana services in the hands of our customers. So there's the idea of the intelligent agent. What that then links to then is into more transactional kind of conversational applications. And we call these bots. You can think about these as the new apps. A bot is basically a chatbot, a conversational transactional bot. So you can potentially talk to a bot over using voice, using text. You could do it over different channels. You could do it over Skype or over WhatsApp or over
So this is actually through the messaging app itself.
Exactly. And it's interesting that most people on their mobile phones, may have a whole load of apps installed, but the highly used apps tend to be messaging apps, whether that's WhatsApp or other messages. Exactly, that's right. And so what you end up with here is the ability to have a computer, a bot, be part of that conversation. So you may have a favourite airline, you may say, when's my flight, and you get a response back. And then the idea that we can then link the intelligent agent, who said, Cortana, find me a flight to Seattle, with the bots from your favourite airline, which then enable you to make that process and execute that transaction. Right. So we're thinking about a world where voice is a critical input, and where you have agents which help you orchestrate your life and some of those decisions and actions you want to take, working with a whole range of different bots from different companies and partners that enable them to take those actions. And so we're seeing a lot of momentum around bots. And in fact, just last week here in Microsoft in Reading, we had 20 customers in for a week-long hack where they were exploring Cortana and bots and starting to build and accelerate their own adoption of bots essentially for their own businesses. So we're seeing an awful lot of momentum around this particular area. Sure. This is a subject which one of our colleagues, Simon Michael, will come back to later in the series. Talk a lot about this idea of bots and this idea of conversation as a platform on which you build solutions. Now, the interesting thing about this is why? Why has bots suddenly become this big thing? And excuse me. It all comes down to this idea of personalization of service. And so the ability that for you and I, we may be able to interact with a brand or with a company in a way which is completely natural and in a way which enables that company to kind of provide a higher level of customer service because that service may know me, may have permissions to use some of my data, and such that you're then able to provide a higher level of ubiquitous, sort of personalised service. And I think that's really important because that's what's driving a lot of interest in this, is that idea of how do you provide better interaction and engagement with your customers, for example. So a lot of interest around bots, but that's just one of the kind of scenarios really which is really kind of taking off at the moment. There's a lot of talk around automating business process. And that's the idea that there's plenty of processes, manual processes potentially, in terms of manipulating data and programs within companies which are now open to automation, because while we may not have found it easy to write the code to automate them, we can now potentially teach the AIs to automate them. Right. Okay. And so this idea that we can automate business processes and automate different tasks within inside a company is something which we're really kind of, we'll see adopted as part of this whole wave of AI. And of course, coming back to the earlier picture around data processing high volume, sorry, excuse me. We've got this idea that we're increasingly going to see businesses using artificial intelligence to take more real-time decisions based on the flow of data they see coming past them. So the ability to detect subtle signals in data, for example, that's flowing by you at a high rate. And combine that with the efforts to digitize businesses and essentially take what a business does and get the data from it and put it in a place where it's accessible and can be used to drive better processes. That's a very, very powerful kind of movement. So where that plays out then is that we talk a little bit at Microsoft around digital transformation, and we talk about that in terms of these four particular pillars. We talk about empowering your employees to do better, about engaging better with your customers, about transforming your own products and services, and also optimizing your operations. And what we see is that we see AI as being really at the core of this digital transformation to these different pillars. And we obviously talked a few examples. So Uber with essentially enhancing their own product by providing driver identification. You can think about optimizing operations using machine learning over company data to find better ways of doing things. And we talked about bots already, about better engaging your customers and actually empowering employees to provide much better levels of customer service, for example. So what we're going to do in the last program in this particular series, May the 9th, we'll explore a little more about this. We'll talk about your digital transformation and how AI can essentially be applied to as part of that. So we'll talk a little about that kind of business transformation language around AI a little bit later in the series. Now, with that in mind, we talked a little bit then around what AI is. We talked now a little bit about what we're doing around bringing AI to market and some of the ways we think customers may actually use it. What are the other implications around AI? Well, I think most people probably heard this particular number by now. A survey in the States showed that roughly 10% of employment in the US is in people driving goods or services or people from one place to another. Right, okay. And whether that's in cars or sort of trucks or whether it's planes. Yep. So you've got this idea that 10% of the employment in that particular workforce is based on technology or doing activity, which is now open to automation with driverless cars and autonomous vehicles. There's another study done, academic study done, which also pointed to the idea that by 2033, that kind of time frame, up to 47% of some knowledge-based worker jobs will be open to some degree of automation, and these include things like legal clerks and some aspects of medical care, for example. So there's clearly something going to happen here around the impact of increasing AI-based automation on the workplace, on digital transformation, the consequences of that. And a lot of the way that's been surfaced in the press and the discussion has been around this, which is this idea of digital disruption and the impact on employment, the displacement of people by the technology, by the AIs. Going back to the earlier discussion around man versus machine and being better at playing games, for example, as we get AIs which are able to automate increasing amounts of jobs and functions like companies, will that lead to sort of displacement of employment? And again, you'd have to be hiding away somewhere not to have seen a lot of the debate in the press and with some key opinion formers around the impact which AI automation may have on employment and broadly on society. So with that in mind, though, for me personally, I'd like to make the case for optimism. Arthur C. Clarke, again, who behind HAL, he had a wonderful quote saying that any person that thinks a lot about the future needs to be an optimist. Otherwise, what's the point? And actually, I think there's reasons for optimism, and certainly at Microsoft we feel that there's a strong reason for this. First off, we have our discussion around AI, around augmentation, not replacement. So, and Satya, when he was on stage at the Davos conference earlier this year, he made an interesting point. He said, it's not augmentation, it's not replacement. It's got to be about augmentation. He said that's got to be a design choice. He said you can come at it and say it's a replacement's the goal or augmentation's the goal. At Microsoft, in our case, we're saying we're looking at ways of using AI to augment the capabilities of humans and make people's lives better. So what we're looking at here is what are the design approaches, for example. So there's a great expression at the moment called cognitive ergonomics. So we're used to the idea of ergonomics. That's how you design a chair to work with the human form so it's comfortable and it's fit for function. The idea of cognitive ergonomics is how do you think about designing human and machine intelligent systems? So the joining up of those two kinds of intelligence so that you get the best out of it, so that you have something which really works and is fit for purpose. So those kind of design rules, that kind of approach to how we think about augmenting human capabilities of machine intelligence, or the other way around, I think that's a really important part of this particular debate. And as part of it, we can talk about some of the uniquely human things which are going to be very, very difficult for AIs to ever replace, and which really give us sort of an ability to think about how humans and machines really do augment each other and work together. So a couple of examples. Transparency and empathy. Empathy is a very human thing, and the ability to understand and to put in context decisions you make in terms of not just the data in front of you, but the person in front of you. Sometimes the computer saying no to something based on the data may be correct, but it may be the wrong thing for the individual in front of you. Right? And there's whole areas around things like medical ethics and others where the decisions you take are informed by the context of the person, not just the things that you see in front of you. And so that empathy, that's a uniquely human thing. Now, there's an area of research called affective computing, which is looking at how do we better enable computers and devices to understand and recognize and interpret human kind of emotions and human kind of wants and needs. But at the moment, it's very much that empathy and the ability to provide decisions which work better for human beings potentially than just the data implies. That's something which is uniquely human at the moment. And so we see that as being a really important part of the design principles, how we think about augmentation versus replacement. The best one, though, is accountability. A neural network is not accountable for its decisions. Right? It takes some inputs and it provides outputs. And interestingly, if you provide a neural network with biased data of any kind, you're going to get something which provides biased decisions. Bias in, bias out. And actually statisticians, when they work with large data, they work very, very hard to ensure that the data sets they work from and they draw conclusions from are unbiased. Right? So there's an element there that we just need to be realistic around the fact that the accountability for decisions, the accountability for outcomes is a uniquely human thing. Right? The neural network doesn't understand the concept of being turned off. It's a network. Right? But accountability for a decision has to sit with a human. So when we're thinking about these design processes for augmentation of human capability, it's accountability and empathy, for example, which come together to really sort of get to the core of what's the unique human value that we bring that can be brought to bear on these kind of automation problems. And then, of course, there's the area of creativity and something called leverage. the ability to think outside of the box, to think of to think of new ways of approaching problems, that is still uniquely human. And actually, AI-based creativity is very much in terms of its infancy at the moment. And the concept of leverage is really important here, which is the idea that by using AI, we can magnify, we can make much more impactful the kind of other qualities we have by taking the robot, if you like, out of a lot of the stuff we have to do.
Yeah, sure. Okay.
And so we can essentially use AIs to do some of the more automated tasks, which for us, part of our working day, are usually kind of fairly frustrating.
Yeah,
and actually apply that to be far more interesting and use the AI essentially to make more of ourselves in terms of work environments. That's what I mean by the word leverage. And we've got a great example here. So if you're ever unfortunate enough to suffer, for example, from a brain tumour, you'll go to hospital and you'll have scans done.
Okay.
And where these scans work is you essentially sit in the machine, it takes sort of layers through your brain as it takes images.
So it takes a lot of photos, basically, of the inside of
Exactly. And then what it does is it takes all those sliced images and builds them up into kind of a three-dimensional picture. Right? The problem here is that it takes a highly skilled radiologist or oncologist. They have to sit and they have to go through each of those layers and mark out which tissue is cancerous, which is precancerous, and which is healthy.
Right, okay.
And it's a laborious process that can take an hour to 2 hours sometimes.
Yeah.
It's highly skilled, requires a lot of knowledge, but it's laborious, it's robotic.
Yeah.
And it's a process which doesn't really add to the, once you have the image segmented, only at that point you can then start thinking about what's my treatment plan.
Yeah. Okay.
And how do we look at this? So out of our Microsoft Research Lab in Cambridge with one of our researchers, Antonio Criminisi, we developed a solution called Inner Eye. We're working with Addenbrooke's Hospital in the UK on this. And it can take this process of segmenting this tumour from the various sliced images to create these kind of models down from hours to minutes.
Right.
I mean, it's 15 to 45 seconds.
Wow.
It doesn't detract in any way from the skill and the judgment and the clinical decisions of the doctor.
Yeah.
What enables the doctor to do is make faster decisions and better decisions based on taking the robot out of that process and giving it to the AI to do.
Yeah.
So this is a fantastic example of the kind of augmentation and how we can make high value processes even better and make them work better using things like AI automation and technology.
Yeah, it really gives the doctors the time to get on with the important stuff of diagnosis and
exactly.
treatments. That kind
and
of
at a time, if you are faced with this unfortunate, devastating position, clearly the one thing you want from your healthcare professional at that point is time to understand your treatment options and likely outcomes and so on. And the fact that essentially we give time back to the medical professionals to spend with their patients rather than dotting images on a screen to understand the tumour. It's a fantastic example of augmentation.
Absolutely.
And that kind of leads on really to a very interesting kind of discussion. So if we think about the way in which AI and automation will play out, economists talk a lot about this idea of employment polarization.
Right.
And so what we've seen actually repeated over the last decades has been really strong, robust employment growth in high-wage, high-education jobs. Right. At the same time, we've seen really strong, robust growth in lower-wage, lower-education jobs, so services industries, for example. What we've seen is starting to be a bit of a stripping out in the middle of those sort of middle-wage, middle-education jobs.
Yeah.
And it's kind of like what they call a dumbbell effect, right? So the idea that increasingly employment is weighted at either ends of this particular spectrum, and we're seeing a strip out of the middle. And the reason for this is pretty obvious, and that's that so many of the processes and the jobs sitting in some of these middle areas have been open to and will increasingly be open to software-based automation.
Yeah.
And this exact issue of polarization of employment on the back of automation is what's been driving a lot of the discussion in the press and with opinion formers around why AI potentially will cause further sort of division and potentially stratification within society. So that's where that discussion really comes from. But again, I think it's interesting. There's a fantastic TED talk, and if you bing for this, he's an MIT economist called David Autor. So if you search for David Autor TED, you'll find his talk. He talks about the reason to be optimistic, and talks about the fact that through previous waves of change, whether it was the Industrial Revolution or whether it was the rise of automation in agriculture in the United States, for example, at the turn of around about the 1900s, what we've always seen is the fact that jobs just aren't replaced and never come back. We've seen other growth and other innovation drive employment growth from it. So the whole tech industry didn't exist, but when employment growth dropped from 40% of the US workforce to 2% over the course of that revolution of automation in agriculture, other jobs, other industries sprang up.
Yeah.
And so it's a fantastic talk if you do that, but it does talk about the fact that there's reason to be optimistic, provided we do the right things in terms of investing in skills and making some conscious choices over where we do and don't apply this kind of automation. And for us at Microsoft, this really comes back to essentially a discussion around empowerment for us.
Yeah.
So if you think about where we've been with this program, we've talked a little bit about what AI is.
Yeah.
We talked a little bit about the technologies as a part of it and how companies like Microsoft are starting to bring that to market. And on the back of that, how companies may take AI and use it to improve processes, and improve customer engagement, and maybe transform parts of their business. Well, where we end up with this discussion is back to one that it's vital, and Satya said this on stage when he was at Davos. He said that it's vital that there's broad inclusion and participation in the economic growth that will occur on the back of AI and automation.
Right.
And it's that message of really sort of inclusion and participation which we're taking forward as Microsoft. So we've captured that inside our mission statement that we've now had for a few years, and that's the idea of empowering every person and every organisation on the planet to achieve more. And I think for us at Microsoft, at this with the wave of AI that's coming and its application to business and to commerce, we see it's really important to think about the message of empowerment, both of people and organisations, to achieve more and participate in this wave of growth that's going to come out of AI.
Absolutely. Well, thank you, Rob. That was a very
pleasure.
fascinating overview. I can't wait to dive into some of these topics in more detail over the next few weeks. I think just to close out with, we've got a video here from a colleague of ours, a guy called Sakib, who works for Microsoft the UK. And he's developed some technology to help him see the world around him. It's really, I think it's a very good example of empowerment and a very encouraging example. So let's just have a look at that.
I'm Sakib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
Hi. Hi, join me next Tuesday at 12:30 on Channel 9, where I'm going to be talking about cognitive services with Martin Beebe. Cognitive services is a great range of APIs that let you bring some of the smarts and machine learning into applications. We'll also have a companion show called the Code Behind series, where Martin's going to really drill into the technical details behind some of these services. I'll see you next week.